Hello everyone, today we are starting with a new series, Mathematics, and the first chapter we will be doing today is Number Systems, alright? So, let's get started right away. In Number Systems, the first thing that we will deal with is what kind of numbers do we have. So, numbers are divided into two types, real numbers and imaginary numbers. Real numbers are all those numbers that can be represented on a number line, okay? So, real numbers are represented by R. The set is represented. Then real numbers are further divided into rational numbers and irrational numbers. Alright? So, we know that they are divided further into rational and irrational numbers. Rational numbers are represented as Q. And then rational numbers are further divided into integers, fractions and decimals. Integers are either Z or sometimes some people write it as I. Now in this chapter we will mainly deal with the rational numbers and the irrational numbers. Alright, this is our main topic in this particular series with this particular chapter. Okay, so let's get into discussing rational numbers immediately. Okay, we will start with rational numbers and then we will go on to discussing irrational numbers. In this thing and then we will start. Yes, so we will talk about rational numbers. Rational numbers. Okay, what are rational numbers? Rational numbers are any number that can be represented in the form of P by Q, where both P and Q are integers, okay, and Q is not equal to 0. That's it. Any number, it can be any numbers. For example, 0, 1, minus 1, 1 by 2, 1 by 4, 100 by 99. All these numbers are rational numbers because in all of them P and Q, now 0 can be represented as 0 by 1, 0 by 100, 1 can be represented in similar ways. We can put 1 for denominator anywhere in any of these, okay. So all these numbers, they can be represented in the form of P by Q, and in all of them these two numbers, the P and the Q, are going to be integers. And Q is not equal to 0. Now you cannot say that 1 upon 0, this is not rational number. Okay, 1 upon 0 is not rational number. In fact, 1 upon 0 is not defined. It is not defined. 1 upon 0, whenever you have this, you will say that it is a not defined number. Okay, the rational numbers are only this much. Now when we go into it and we will see what are the properties of a rational number. Okay, we'll quickly look at all the properties of a rational number. Let's see. So the first property is where there are two rational numbers A and B such that both of them, A and B, not that A, there are two numbers A and B, both of them are rational numbers. Okay, now Q is the set for rational numbers. So this thing means a set of A and B, that is both the numbers A and B, they belong to Q. So A and B, both of them are rational numbers. If this is true, then in fact we can do this for all of them. So if this is true, okay, if this is true, then the first property is A plus B is also a rational number. Okay, second property is A minus B is also a rational number. Third property will be A multiplied by B is also a rational number. There's also this fourth property, A divided by B is also a rational number. But here you have to be very careful that B is not equal to 0 or A is not equal to 0, because if A upon B is a rational number, this is also true that B by A. For this it will be B into A. This doesn't matter really. But in this one B minus A and in this one B plus A. We can write it this way also. Now here While in this one you see that only b is in the denominator, a can also be in denominator. So you have to realize for this fourth property in particular, a should not be 0 and b should also not be 0. These are true and required only for this fourth property. That's it. Okay. After this, there are some more properties about them that I will tell you, but these were operator properties. These are called operator properties. The four basic operators in mathematics that we have: addition, subtraction, multiplication, and division. These were operator properties. Now there is another property which says that if there is a and b, then if both of them are rational numbers, then they are in some kind of order where either a will be less than b, or a will be greater than b, or a will be equal to b. There has to be some order in them. Okay, this is, let's call it the fifth property. There is another one which says if a comma b, they belong to rational numbers, then there lie infinite rational numbers between them. Rational numbers between a and b. The next thing we do is we will find out how we can find the rational numbers between a and b. They can be infinite numbers. Okay, so the next thing that we will talk about is inserting rational numbers between two rational numbers. Okay, so let's clean this up and quickly jump on to going for how we insert rational numbers. Okay, let's change this. We will call it inserting right now. Okay, inserting rational numbers. Yeah, I'm trying to be very efficient with this thing. So inserting rational numbers. The first thing, let's say there are two for example, let's first take an example. Okay, example 1. You have numbers, say 5, 6. Both of them are rational numbers. You have to insert one rational number between 5 and 6. Okay, the one thing you can do here is a number between 5 and 6 will be 5 plus 6 by 2. This is also the average of 5 and 6. Average of 5 and 6 will lie between 5 and 6 only. Average of 5 and 6 will be 11 by 2. That is 5.5. So 5, 5.5, 6. Now you see this is p by q. P by q, where p and q, both of them are integers and q is not equal to 0. So this is a rational number and this will be between both of them. Okay, this is how you can do it. Now this was a question where you were asked to insert only one rational number between 5 and 6. However, if you were asked to insert two rational numbers between 5 and 6, this is how you would do it. You take 5 and 6. The first number you will find out is 5 plus 6 by 2. That is 11 by 2. So 5, 11 by 2, 6. Now for the second number you can insert it either here or here. Now since both of them are rational numbers, you can simply take, say, you take this set and you do this same method again. That is 11 by 2 plus 6, whole thing divided by 2. That is what? 12 plus 11 upon 4. That is equal to 23 by 4. So the next number you will have will be something like this: 5, 11 by 2, 23 by 4, 6. You can insert a rational number between two given rational numbers by simply adding them and dividing by 2. But this will be a long process. I mean, see, you had to find out a rational number first between 5 and 6, then you had to find out a rational number. Now if you were asked, say, multiple rational numbers, say 5 rational numbers, that would be if you had to insert, say, 5 rational numbers between two given rational numbers, that would mean too much of work. Either you can spend a lot of time and work doing it this way, or there is another shorter way, easier way to do this. Okay, so let's take this example itself. We are given 5, 6 belongs to rational numbers. You have to insert 5 rational numbers. Okay, insert 5 rational numbers in between. What do you do? Now, we're not doing this the earlier method. This is the smart method. This is the smart method. What do we do here? The first thing we do is, this is 5. That means this is how it will look. 1, 2, 3, 4, 5, 6. Okay. And you see these gaps that you have to create. See, you have to create this gap. 1, 2, 3, 4, 5, 6. Okay. This gap. So you have to create 6 gaps. How will you create 6 gaps? You will divide the given numbers by 6, but you don't just divide them. You cannot, if you just divide them, you'll change the value. So that means you want 6 in the denominator. You want 6 in denominator. How will you do that? 6 in denominator for this would mean 6 into 5 by 6. Same for this. Now if you multiply and divide by 6 here and 6 here, you're not changing the value of the numbers. But now what you've done is, you've made it very easy for yourself. What is this value? This is 30 upon 6. This is what? 36 upon 6. Now what you can do? 31 upon 6, 32 upon 6, 33 upon 6, 34 upon 6 and 35 upon 6. Okay? See? Okay. That is one of the ways to do it quite easily. Now let's try and define it for general. So now, as of now, I was doing this, but you see, you have to define it so that you can do it for any n number of insertions that are required. Okay. So let's see if we can do it now with this. We will do this. Let's say you're given 2 numbers A, B. They belong to Q. What will you do? You have to insert how many numbers? Say n rational numbers between them. So you will do this. A into n plus 1 by n plus 1 and B into n plus 1 upon n plus 1. Okay. Now you have created n plus 1. So if there was, for example, in the last one you wanted 5, so you created 6 gaps. So this will create 6. This will create 1 extra gap that is required. Okay. So now once you have this, all you need to do is the number of insertions here would be very simple. You have to start with doing this whole thing plus 1, then again this thing plus 2, A into n plus 1 plus 2, A into n plus 1 plus 3 till you reach B into n plus 1. Okay. Once you reach B into n plus 1, that means you've reached your values. So this value here, just before B into n plus 1, all these values, of course, these will be divided by n plus 1, this will be divided by n plus 1, this one will be divided by n plus 1, this is also n plus 1. Okay. These will be the rational numbers that you have inserted between A and B. Because see, B's value doesn't change, A's value doesn't change, but you have also found the rational numbers that will exist between them. Now, by this also we can prove that last property that we talked about, that there are infinite number of rational numbers that exist between any two given rational numbers. Okay, because this n can be any number. You have to just simply do n plus 1 and you can start dividing, and you will find n those many rational numbers. So it is infinite rational numbers that exist between any two given rational numbers. Okay. So that was all about rational numbers. Rational numbers are easily locatable on a number line. You can easily locate them on number lines. That's not a problem.